This conference will now be recorded.
Right. We're going to discuss about indexing in Mongo and what kind of indexes we do create and how indexing will help to retrieve the data more efficiently, how we can see execution plans in Mongo, and how we can see that index is really getting used or not. What are the patterns we need to follow to create the indexing, and everything we will see in detail. So indexes are common across any product related to database technologies. Any technology you take it about it, RDBMS or NoSQL, indexes will make the query, quicker to reference the data and pull out from the hard disk. So indexes supports efficient execution of queries in not only in Mongo, in any product, in fact. Without the indexes, MongoDB must perform collection scan, and collection scan in the sense, that index seek, index scan in RDBMS. So scanning is everything, reading everything from the collection, which is not good, right? If you read everything for you have 1 billion rows, but you wanted 100 rows out of it. If you're reading 1 billion and giving 100 records out of the system, which will be huge impact, right? So we will see that how the index is really helpful to retrieve the data with a more efficient execution plans. If an appropriate index exists for a query, MongoDB can use the index, and that can limit the number of document it must read. So even if you have 1 billion records, but I need only one record, I can read only one record if you have a proper index. If you don't have a proper index, for reading one record, it will read 1 billion record. Okay, 1 billion records. That is something not good. You definitely have to have some indexes to support your queries for a better retrieval of the data. So we will see in practical anyway. I'm going to talk about all the patterns, how MongoDB uses the indexes internally anyway. Okay. So indexes provide high performance read operations for frequently used queries. Generally, the indexes are helpful for the read operations. Okay. So even it will help update queries also, but for mostly the indexes will be used for the read operations. Indexes are special data structure that stores small portion of the collection data set in easy to traverse the data. Like you wanted to reach some data and some condition. If it has to find the data, it will refer the index, it will go to that address location, fetch the data straight away. It does not scan the entire data that collection has, right? Fundamentally, indexes are similar in MongoDB, similar to index in any other database system. Indexes are everywhere similar. There is no difference. If you take about MongoDB indexes, we have a lot of different types of indexes. We're going to go one by one anyway. So let's go one by one in detail. Okay. So single field index. So let's go and connect to the Mongo and show DBs. Use lab database. Show collections. Some random data. Let's pick and work on it. Show collections. db.cls. Show collections. db.student. It is, you need to understand this. Okay. Student.find. Okay, we have this data here. So now I wanted to read data from this, like on one particular field as a condition, right? So I wanted to give where s number equal to 2, assume a case. So db dot student dot find, I'm giving condition as s number 2. So how many records still pull out? Wherever 2 is there. There's 1, 2, 3, 4, 5, 6 records. It has to give 6 records out. You can see that 6 records came out. But is it reading 6 records only in the background? That we need to verify. How do you verify it? How do you verify the query is really reading required records only, or all the records of a collection? So let's check it. So first we need to check whether our read operation is using the index or not first. Okay, there is something called explain. There is a function called explain. So this will tell you, is your query is using the index or not. Collection scan means it is not using the index. If it is not using the index, how many records it is reading basically for your output to give that 6 records. Execution stats. Okay. So explain execution start. This will give you entire execution basically. So total how many records it is returned? Oh, I gave without a condition. Sorry, I need to give a condition. Yeah. Condition is S number 2. So how many records it is returning? Actually, the execution plan will generate entirely. It is returning 6 records. But how many document is examined? 13 records. We have only altogether 13 records only. If you have 1 billion records in the collection, it will read all the 1 billion records and give you 6 records as an output. Because your condition is asking wherever S number 2, I need that record. To find that record, it has to scan through entire collection. It does not know where the S number is actually available in the entire collection. It has to scan through and find that data in the buffer and give you as a result. So for reading 6 records, you're reading 1 billion records. That is called a collection scan. You're scanning entire collection. Whatsoever the data size that you have, it doesn't matter. Okay. This is absolutely bad. Reading all of the data for reading some amount of data is absolutely performance impact. So all NoSQL platforms are big data. They do handle very huge data, and you need some data for a small chunk of data. You're reading entire data from one collection that can occupy all of your RAM. It is possible. It has to write. It has to fetch the data. When it is fetching, there is a load on the CPU, and there is a load on the IO. There is a load on the memory. Everything is actually flooded with your operation. So you have to make efficient indexes to read your operations. So I wanted to create an index. So now CLS, okay, db dot student dot find. This the same concept applies in every product, SQL, Oracle, any product for that matter, whatever I discuss here. So now I'm giving a criteria. This is called a predicate actually. What you are giving as a predicate and a projection. Projection anyway we are not talking about predicate. The condition is a predicate. So db dot student dot create index. I'm creating an index where I'm actually trying to give a condition on the S number field. So I'm giving this number, sorry, S number 1. What exactly the 1? 1 is saying that sort the data in the ascending order. So what does indexing actually does in the background? Let me explain. The physical sorting of data with the help of the indexes. When the index is created, data is sorted by default in the background. Understand this. You have the data like this. 1, 3, 5, 2, 4, okay, 7, okay, and 7, 6, 9, okay, and 8 and 10. This is how you have the data. Assume okay, so the physical order is not correct. When I create the index on this column where this is holding it, index is example, this column is S number, just for the sake, S number. So when the index is created, I asked what did I ask the system is ascending order. So on the S number, what happens? First record, okay, then it'll make 1 as a reference, then 2 as a reference, then 3 as a reference. It keeps the data in the order, though your physical order is not correct, but index has a correct order of the data with as a reference. It maintains the data in the order. Okay, the physical data is not in the order, but with the index, whatever the data it is referencing is already sorted. So this way, when the system is reading the data with the help of the index, it no need to sort. The data is already sorted with the index. Though physical order is not correct or it is not in the order, but index will order the data. That's how it works, indexing. Okay, so this is called ascending order or descending order. You have two orders of the data. Descending means 10 9, it will come in the reverse order, 10 9 8 9 like that. Ascending means 1 to 10 whatsoever it is already sorted. Whatever the data whatever the index you are creating, the indexing data is sorted. 1 means ascending order, -1 means descending order. That's it. So what exactly the 1 means? We are asking the data whatever is assigned to S number, keep in the ascending order, lower to higher side. So I'm creating an index on S number field Now it said, what it said? Number of indexes before this index creation is 1. Number of indexes after this index creation is 2, which means it is successful. OK1 means always OK1 means your query is successful. OK0 means query is failed. That is most of the queries you run any command in the Mongo. OK1 means it is executed successfully. OK0 means it is failed. Then that number. Okay, fine. So now if I go and read db dot student dot get indexes, get, there is some function called get indexes. It will read all the indexes. Sorry. So we created an index on the field called list number. Now I'm going to read the same query what I was reading before. This is the query I was reading. So previous case, now things will change. Now things are index scan. Previously it went with the collection scan. Collection scan means it will read everything. Now it read only 6 documents. It gave you 6 documents as a result. So it is limited the read. It did not read all the data that collection has. It read what exactly the output need, because you are giving a condition on the field that has the index already. Okay, that has the index already. Okay, so this way indexing will help us to minimize the amount of data that you read, because it has the ready-made references to fetch the data. The ready-made addresses available with the indexing, right? So if I example, let me go clear the screen. I'll ask some questions. db.student.find. Okay, I'm going with the name, some name. Name maybe Pawan, assume a case. You have to answer this. If I read this thing as name as Pawan, it's lowercase. It is a case sensitive. How many records it will read? What do you think? First, will it use
It
index?
it it
That's the question.
it record it no it will read all documents in that collection because we did not create any index on name.
That's correct what you said. So if you see, it is going through the collection scan first. And if you wanted to see how many records it read, it's not actually going, it is not executing the query, it is just telling the statistics. So you can see it without a load on billion records also. Your query, how many records it is reading. First look at the execution plan and then write the query. I'll tell you all that anyway. If you see, it examined all 13, gave you 0. There is Pawan is not matching. Why? This is a Pawan, right? It is S in student as name.
Case
PA.
sensitive. P is
It's
capital.
a oh, P is capital. Sorry, that's correct. Now let's see how many it is actually returned. It read 13. It gave 4 records as an output. So this is also not efficient. If example, if I add S number here, S number 2, okay, S number 2. Before I run this one, I'll ask the question. Let's see what you'll say. CLS db.student.find. Okay, db.student.find. I'm changing the condition. S number 2, comma, S name for 1. Now, how many records it will read? Look at the data and tell me.
Read 6 records and
Hmm.
give the output around 3 names. I think Pawan is name. I mean 4
4
output.
records.
4.
4 records. That's correct.
Yeah.
What you said is correct. It will read 6 records, but it will give you as an output 4 records. Good. So I can see it actually. I can see the execution plan, and I can say that how many records it is fetching out, how many reading, how many giving as a result. So both we can see. If you go to the execution plan, it is reading 6 records, but it is giving 4 records. Is it efficient? Actually, yes, it is a little bit of efficient. Without a collection, it is much better than that. But you have still scope to tune the query, tune your indexing basically, right? So this is called single field index anyway. You have created an index on single field. The indexing referring to only one field. Wherever 2 is there, on that data, the indexing is working, but the rest of the data it is not working because there is no indexing on the combination of the field. Composite index. It is composite index, we'll call it as. So single field index is something where you are keeping as a condition of that single field that will definitely will work at optimum level because you are keeping as a predicate on one field. As long as you are keeping as a condition one field, it is absolutely good. But when you are clubbing multiple fields there, that's where the problem will start. This query has still scope to tune it in terms of indexing. For read out here I have 13 records. Out of 13 it is reading 6 giving 4. If I have a billion records, it will read 1 million, give you maybe 10,000, right? Out of 1 million it is given 10,000. It is possible. Reading 1 million giving you 10,000 is not efficient. Again, you have to make it efficient. How do I make it efficient? Let's do further. Single field indexal, that's all about single field. MongoDB provides some complete support for indexes on any field in a collection of a document. By default, collection will have a ID field. This is something I'll talk in the next slide, or else we have somewhere added. Anyway, default index will see that. Applications and users may add additional indexes to support the important queries and operations. Generally, we use the user fields to sort the data most of the time. So the default index, there will be index will be created on the ID field, which is like unique data. It will get a index on it. If you wanted to sort by default, you can sort on that one on the ID field because it has a index by default. That is the most efficient if you don't have indexes on the fields. Or sorting on the ID field is good. We will see in the future indexing tomorrow. I guess I'll cover this. The following command create the index on the name field in the ascending order. The ascending order means physical order is not actually in the order, but logical order with the indexing is absolutely in the order. When I'm sorting on the S number, it does not sort the data. It is already sorted in the as a reference in the index. Index treat as a sorted data. It gets data in the order by default. So sort does not take time because sort has the data references to fetch the data in a more effective manner. Right. Index on embedded field document.
Ravinder, one query here. Usually, if we query any select, if we query the find on any selection, I mean collection, that will be stored in the temporary location, like other RDBMS.
Temporary location, there is no temp tables here.
I mean, not like this buffer location.
See, if you are reading the data, it will be in the buffer till the next data is not loaded yet. It will work circular buffer, right? Everywhere circular buffer, like new data will come, old data will flush.
Okay, got.
That's usual everywhere. Any product, that's how it works. Right. Let's go to sample. db dot sample. I guess somewhere I discussed about embedded document. Class cloud somewhere. I mean, let me see. I mean, I don't want to write again, so that's the reason I wanted to just refer it. If I have it, I can directly talk about it. db.employee, I guess. Somewhere I made some embedded documents. Right, this is exactly I wanted. To talk about embedded index on embedded fields. So now db.employee dot find and pretty to read the data in much readable format or organized format, you go with the pretty option. So now you have the two records here. In fact, three records, 1, 2, and 3. And this is called embedded document. We discussed this embedded document in detail when we were talking about initially as an example. So now I'm reading address.street, okay? And this one, let's read this. I wanted to read where OU colony. I wanted all those records. So how do I read it as a condition on that? First, what you have to do, you have to give the quotations, and first field, the parent field, address dot street, and what you call it, that you have to give it address dot street. Okay, come on please. db dot student dot find. Okay, come on. It is the same thing, but on what pattern you're reading that matters, means what field you're reading it. Oh, you colony, it should be a case sensitive, so you have to match case. Okay, if I'm reading as it is like this, how many records it will read? It is not giving anything. Is spelling is wrong. Address dot street, OUCOLONY, right? ADDRS street. Where we went wrong? Oh, it has to be employee. The collection name is employee called student. Sorry. No, you got one record. But how many records it read in the background?
No
All,
index means
because it
it
doesn't have
will
index in it.
it's no index, right?
That's it. No, yes, you are very close. You are making conclusion statement. Actually, no index means it will read everything. It has like this. Collection scan, it is reading total 4 documents, giving you 1 document as a result set. So I don't want that. I wanted to read a specific embedded document. So if you wanted to read this all the time, you create the index on this one only, on these 2 fields. If you wanted to read this one and this one as together, you have to create a composite index, like on the address.street one index, address.city as another index. So whatever you are giving as a condition, that need to be part of the indexing fields, as simple as it is.
Sorry, we lost you, Ravi.
So now what I'm
Try
going to
again.
do, I'll change this to
Others can hear, right? Oh, okay. You are back.
create. Sorry.
Your voice was breaking earlier. I
So
think now
now
it's good.
I'm creating index on the embedded fields. Is it okay now?
It's okay.
Is it clear?
Now we can hear
Okay.
you, Ravi.
So now see. Okay, good enough. So db.employee.create, and we are calling the parent field and the child field, which is embedded document. I'm creating the index on this 2 fields combination. If I create this, what happens basically? The index references will be created on that part. So it is straightforward, nothing else in this. So now if I go and read the same query with execution starts, it'll read only 1 document. It'll give you 1 document as a result set. It knows what you're trying to read. It exactly point the system to fetch that particular record because it has the address of that location in the index field. So that way you can create the indexes on the embedded documents also to refer whatever you're giving in the condition, that must be part of the indexing. That's so simple, you have to make it. So now this is called index on the embedded field and document basically. Let's work on the compound index. These are all very important, especially. Let's go with it.
Ravi, if you have an address field, right, and the address, let's say embedded document, in the address we have multiple columns, street, colony, and all, right? So let's say if you
Right.
create an index, but if you're reading some other column, again it will be a problem, right? Do you have something like include? Can we include whatever columns are there in the embedded document within the same index, whatever index you created, right, for address field?
Yes,
Can we?
yes, comma. You can do that. Street dot address dot street one comma address city comma one. I'll do that straight away. We are talking about it.
Okay.
It is simple. So use lab database. I'll talk on this collection, so you'll get it. So collections db.student.find. Okay, CLS. So now you have this data. Whenever I'm trying to read data on the S number 2, S name Pawan. Okay, I'm giving condition on two fields. It can be embedded, it can be non-embedded. Two fields as a condition, the index must cover these two fields in a single index. If I read this one, as already read this one, it is reading actually 6 records but giving you only 4 as an output. That's not good actually. As an efficient execution, it's not efficient execution plan. It is reading 6 documents, giving you 4 documents only. This is not good. This is definitely not good what you are trying to read. It can impact your system performance still. So what should I do then? What should I do? What do you think? We have to
You
cover
need to
that field
create,
also in it.
yeah, you need to create index on that is name also then.
Right, that is called included column kind of thing here. We have in the RDBMS. So here also it is a compound index. S number in index, comma, S name 1. So we are creating single index on 2 fields. Okay, we are creating index on 2 fields now. So now there are 3 indexes now. If I go to and read the query this time, it will read exactly 4 documents only, because index has S number and S name together. It will find the 2 fields uniquely. It does not go to every 2, because there is an index which is covering 2 fields as a condition what you have given. So if I go and read this one, it will read only 4 records, give you 4 records only, because these conditional fields are covered under the index. Okay, getting the point? So no.
Yes, right. Yes.
All right, let's move further. db dot, I'm taking you very deep slowly. Try to understand, because this applies in every product, not only in Mongo anyway. Now I'll go with the let's go and read. This time I'll go with the 3 fields. Let's see how it works. S number 2, S name 1, and address. Yeah, it works, I guess. Address as Hyderabad, HYD. So now, how many records it will pull? How many records it will read?
I think 0 records or what? Because address is HYD. Okay, fine, fine. Sorry. Okay.
It's 4 records
How
it will read and return the 0, I think. No, one
Zero?
record. It will return. One record it will
Ah,
return.
you guys are good enough
Because
then. You guys know how indexing works then. If you know this, you know the indexing as simple as it is. So that's good. What you said is absolutely good. It is reading 4 documents, giving you 1 document. Is it effective? Is this query, I mean, is this condition is not effective against the indexing? If you wanted to read only 1 record exactly instead of 4, then what should I do?
we have to create index for each column. I mean, each
Ah,
Each
identity,
field.
each field.
that's correct. So I'll conclude it now. You guys are very good in terms of indexing understanding, it seems. Right, now what I'm going to do, db
But
dot,
Ravi, in the real-time environment, lot of fields will be there in each collection. How can?
wait. That's what the conclusion I'll come to. First understand the basic, then I'll come to the conclusion. First you need to know how indexing works. Then I'll come to the conclusion, okay? How you make efficient indexing. Not all the indexing useless indexes. We have to make an efficient index which covers all the patterns what people are reading. One index. So that's what the ultimate discussion. But understand how index works. That's first motto. So now S name, S number, S name, comma. What is that address, right? Address. We are creating the index on 3 fields now. The same way embedded also. There was a question embedded. Address.street 1, comma address.city 1. So 2 fields are covered in that index like this. So now if I'm creating an index on 3 fields, in fact, okay, Now if I go and read the previous query as Pawan and address, how many records it will give? It will give only one record. It will read one record, it will give you one record. Right. Now the question is, immediate question I got it. How do we know that there are a lot of fields in the real time, and how we can make efficient? That's a very good question. Let's work towards that side. So now you know data pattern. First, what patterns people are reading, that you need to understand. Don't create the indexes blindly. First, understand their pattern of read and conditional pattern. Okay, now what I'll do, let me tell you this. If I have db.student dot find, sorry, not find, get indexes. This is the conclusion of your question. Okay, follow carefully. This will help you everywhere, in fact. So now you have these many indexes. Do we need this many? If I delete this one, what happens? If I delete this one also, what happens? I keep only one index, what happens? Let's see. This is where the conclusion will come. Drop index. Okay. I'm going to drop index name is this one. It is dropped. I'm dropping this one also. Right? So now if I go and check get indexes, there are only two indexes. One index here and one default index. Now let's come back to our original discussion. So db.student.find, if I'm giving a condition on s number one, okay, I'll give everything, not an issue. If I'm reading only s number one, how many records it will read? S number two. How many records it will read?
6 records it will read.
6 records. That's good. Explain. Execution starts. You don't want to execute, it only get the stats. That's very good. You have to read this before you execute. So it is reading 6, giving you 6. Good enough. Now again CLS db.student find again. I'm going to go and I'll keep it sname as pawn. How many records will read now?
It will be 4.
Four
Read
records.
it will read 4 and it will do the same.
Right.
It will return 4.
4 and 4. Good enough. Again db.student. Now you'll come to your question answer yourself. Now db.student find is number 2. Its name per 1 and address. How many it will read?
Only one.
So we created multiple indexes, but one index is actually satisfying all conditions. So this is what you need to consider. I'll explain, no need to worry again. So it is reading one record, giving you one record. So let me explain and conclude this entirely on this one. So we have a s number 1, comma, s name 1 index. Just follow. If you follow this, you easily know all indexing in the RDBMS also, not only here. So read pattern. What people are reading, that matters next. Read pattern. You need to read, you need to understand the read pattern, not just the index, okay? This is important. So what are the ways this index can actually serve the index? S number, only S number, okay, only S name, only address. These are the combinations, people can read it. I'll tell you, don't worry, I'll conclude it. This is a very big discussion for us. S number 1, these are the fields in the condition. S name 1, S number 1, comma, address 1. Okay, S name 1, address 1. This is another pattern. 1. Then address 1. I'll give you, I'll show you everything as an output. No need to worry. This is another combination. What is other combination you think of? Right. Do you think of any other combination? S number, S address, S number, S name, S number. Okay, now.
All three.
Yeah, all three. Yeah, that is the next one anyway. S number, S name. This is another pattern. S number, address, S number, S name. This is another pattern. S number, comma, what? S name, S number, comma, S address, S name, address. These are all combinations people can read. We are trying to understand all patterns. Then you understand overall indexing. Okay, this works in every product, in fact. These are the patterns people can read with one single index. Right. So these many ways people can read. So with this, will it use index? We tested already. Will it use index?
Yes, it will.
We already did. With this, we'll use the index, the current index. Let's check it out, every combination, and then understand. So what I'm trying to say here is, I wanted only read S name, though it is part of S name. Pavan, explain. Will it use index? No, it won't use index. I'll conclude at the end. No need to worry. So it won't use indexing. It is reading all 13 documents, giving you 4. So this is no. No, it is not using index. So now next last one, address. So in the here, I'll go and use address. It will read all 13, give you 3. It is also not using the collection scan. You can see this. Previous case also collection scan. So no indexing getting used. Now S number and S name. Will it use index? We did this already.
Yes, it will use.
That's fine.
Yes, we did it already. So I don't need to even see it. S number and address. This is a tricky thing you need to understand. This is where people do and go wrong. db dot student dot find. Now S number 2. Okay, and address. I'm breaking the sequence. So how many records it will read? Anyone? If you answer this, you know the indexing.
It will read 6 records and return
Okay.
the where the location Hyderabad 1.
That's good
Return the
actually. If you
value
say
1.
Only one record it will return.
right, actually it is looking for 2 independent. See, if you look at here, it is reading total 2 at the end, but there are key lookups. It went with the key lookups and the address field. And the address field, it went with the key lookups. It returned 2 and it is examined 2, but it went with the key lookups. There is a concept called key lookup in the RDBMS also. If I go and read this one, Hyderabad, wherever the Hyderabad, here is Hyderabad. and here also in Hyderabad. It went with this one. It went with the 2 combination. See, S number 2 also is Hyderabad is here. S number 2 6. Out of this, it is giving you 2, but it went with the key lookup with all other fields. It is giving you only as a it will give you 2 records as an output if you go with. But how many records it is reading?
5 records.
It is reading 5 records. Why it is reading 5 records? Why? Because this field, it is using the index. Yes, is using the index, but with key lookups. Key lookups is also not efficient. This pattern is using the index, but not entirely. Now this combination, will it use index? Yes or no? By looking at it.
No. Okay.
Absolutely no. I'll conclude it at the end. No need to worry. You might confuse a little, but I'll conclude again. This is the data. db dot student dot find and s number. Sorry. S name. Pawan. Address. How many records it will give out? First question. Sorry. How many records?
Only one record. One record.
It will tell you anyway. So it is giving 1 record, but it is reading all your document. It went with the collection scan. So this pattern is no. And this one, reverse of it. Will it use index?
No.
No, absolutely no. And this one?
Yes, it will use index.
Yes. And this one?
It to index. Yes, it also will go with index.
I'll conclude here. This is where the question will be answered, what you asked in the beginning. How to create the index when there are hundreds of fields? So this is where the conclusion will come. So I'm reading S number, S name as Pawan. Okay. S number as 2 and address as Hyderabad. How many it should read?
It will read 13 records.
It will read 13?
Yes.
That's where you need to understand. Actually, as long as all indexing fields are supplied, the order can be any order, it doesn't matter. You supplied all indexing fields, so it will use only 1 record. In fact, it read 1 record, gave you 1 record. So the pattern can be anything. If you include all the indexing fields, then it will use index. It no need to be order. Order can be broken. It will go with order only. It will sort that field layout automatically. So now with one index, I can make people read the data more efficiently. These many patterns. Understand now? What you're reading, what the people are reading, you need to understand the pattern, not one query. You read all, you try to understand multiple queries and try to create one efficient index which will resolve or which will serve all the read patterns.
I think now we think we can include all the field in the indexes. It will be efficient.
No, how you can do that? Do you keep all the fields in the condition all the time? Never.
No, not like that. Never. Just asking.
But no, see, if you are keeping all fields indexed, still there are issues, right? If you are breaking the first field of the index, then you're gone again. That index doesn't make any sense.
Yeah, I got
Wherever first field is missing, then index does not make any sense. You see, wherever the first field is included, index is used. The pattern, this wherever this field is used, index is used. If the first field of the index is missing, there it does not use the index. So you created index on all fields. Do you think that first field of that document will be supplied in every condition? No. Will that serve the purpose? No. So you need to create one index which will serve a lot of patterns. If people don't know, educate them. You have these indexes, you follow this pattern. If you give me one pattern, or if you're reading what pattern you're reading, tell us, we will create efficient index in the background. I guess you guys
depends on
following
the
what I'm trying to say.
fetching.
This applies.
Depends on the which pattern they are fetching the data. We need to create the index, right?
That's correct. The most of the patterns, see, don't go for one pattern. Try to analyze more patterns, and which is actually create a common index, which will see, in this case, people can read these many patterns on 3 fields, or a single field also they can read like this, or 2 field also they can read this pattern, right? They can read this pattern also, at least it is somewhat better. If they read any of this pattern, still the index is absolutely good. Look at the pattern. How many patterns people can read it with one single index,
Yeah, in
right?
the actually, Ravi, in the real-time environment, any developer or any end user will fetch the data in the common query only, like common
Hmm,
query only regularly. They don't change the query. Okay.
hmm,
Uh,
hmm.
at that time, we can decide it's based on the query. We will create the index. If they change the query means
That's it.
we need to change the index also, right? You're saying
Yes,
as
of
per
course.
the
See, simply,
yeah.
your conditional fields must be covered under the index. Even in every Oracle, you take it Oracle, you take it SQL Server, whatever you giving as a condition should be part of the index. If you are reading more projection, that need to go into as a included columns, because you are projecting more fields. So the more fields you read it, the more references you need. So one index can serve all the indexes reference, all the fields references. It will go that way.
If we create then
It's
any
little
other
more
Ravi,
for
index,
us.
One thing. So I have 5 fields in my collection, and I created on the second field. Imagine second field I have created an index, okay, and by using that second field, I can use remaining 4 fields also, right? So that index will start. And one to
But again,
anything, but mm,
no. See, again, if in our case itself, that's what I started. That's where you need to understand. So I created an index on the S number field, one index on the S
okay.
number. Okay. When I give S number as a condition, it absolutely went well. When I joined S number and S name, it did not went well. One field does not service all other field combination as a condition. That's what you need to understand. With the one index, as long
Okay.
as you're giving a condition on one field, you're good. But you're joining one more field in the condition, then it will go with the key lookup. It use the index, but
example,
it will go with the key lookup.
Ravi, regularly they're using one all the field or some fields using the fetching the data. Okay, in the query, but they changed one field is missing. We need to create the another index for that query.
You need to look at how much data is going through the key lookup. It is less, no need to create. If it is too much, then you have to put.
Just check the explain and after that only we can
That's
decide,
it.
right?
Yeah, that's what we are checking it, right? How many records it is examined, how many it is written. If it is how many keys examined, right? How many keys examined? If you look at keys examined, this also matters. Keys pattern
Yes,
is
I
this.
got.
This is the indexing it is used. And how many keys it is examined before it is given. This one, total keys examined. It also should match with this one. If it is not matched, which means it went with the key lookup. There you need to focus. If the return value and keys examined is difference is too big, then you have to include that, whatever you are
Yes.
keeping.
Yeah,
That way it
got you,
is.
Ravi.
It is simple. Indexing is simple, any product. You just need to understand the logic behind how the system uses the index. Okay. This concept is similar, guys. In any product, you go to any product, is same. There is no difference in it. So is it clear on the compound index now? This is what is a compound index. Index on multiple fields is
Yes.
a compound index.
Okay.
Again,
One thing, Ravi. So in my case, if for performance issue, mainly indexing comes into picture. So I'm facing that my customer is not getting data in a collection from a collection for a long time, and I need to create index on some field, but I don't know on which field I need to create. Like in RDBMS, we have execution plans, like explain query, some three types of there. So in MongoDB also, do we have any like any option that we can find and which field we need to create index like that?
that's what
That's what
when
it
you
is
are
the explain
reading this,
status.
the explain is entirely telling you everything. What you are
Mhm.
reading, see, if you look at this execution plan, what you're trying to read on the address equality, sname equality you're giving, these are the three fields you're reading it as a condition. These are all fields you are including the condition, basically. This is a condition, basically. So what index, the key pattern, how many indexes it is used, how many, all the fields are included. See, s number, s name, s address, it is included. So it is satisfying the index. If it is missing, the keys are s number, s address, but you're reading all these three, it will go with the lookup because it is missed on one field. So you need to understand the execution plan. It is not reading the data when you're generating the execution plan. It is looking at the statistics and giving you. It is not reading the data. Okay. It is like estimated
Okay,
execution
okay,
plan.
okay, fine. Yeah.
So that way it is. It is equivalent to RDBMS, of course. So that's all about compound index. So how many fields you go up to, you might go with the 4 field, you might go with the 5 field index. The pattern matters there. Pattern on which you are giving as a condition. What patterns people are using. One index can serve more patterns, right? So that is what you need to catch. If people are reading, let me tell you one thing. If people are, reading most of the queries, s name, s address, okay, s name, s address, you have the index is this one. Indexing is absolutely omitted, right? So you ask them include the first field. You don't need to create a new index for that matter. Ask them to keep as a predicate, but in the projection, whatever the fields they wanted, they can include in the projection. But condition, ask them to include, to use existing index, get the benefit of existing index. Okay, they are giving a condition on 2 fields. Okay, if this is a regular pattern, create the index on the fields. Again, it is definite. They need only these fields as a condition. You can have this index also, you can have this index also, because it is also one of the regular pattern they want to read it. There is no other way, because first field you wanted to miss it. Again, with this indexing, this also will be covered, this also will be covered, and almost every pattern will be covered. So look at one index which can satisfy more of patterns. That is your target. Creating too many indexes also create a lot of mess, a lot of performance impact. It is also take
But
data space.
Ravi, we have multiple indexes. Mongo will, Mongo will select the most powerful index related to that
That's what the
query.
optimizer does, right? That's
Yeah,
what is a system does in the
he
back.
runs
What is a indexing
inside.
means what? What is a efficient index that will satisfy the condition to retrieve the data? That is the meaning of index. That is system. Any
Here
product you
also optimizer will be there.
optimizer means Mongo engine kind of. There is no
Mongo.
such kind of optimizer kind of thing, but to make you understand, I use that word.
Yeah, okay. Is there any concept in here? Mongo engine.
No such thing. They did not talk about any optimizer in the any of the architecture in entire Mongo documents.
Yeah,
Basically,
I didn't hear this. That's why.
I am just referring you to make you understand. That's it.
Yeah, okay, good.
it has that engine intelligence to make that call. Okay, fine. So MongoDB supports component indexes where single field index structure holds the references to multiple fields, one index and multiple fields within a collection. Component index can support queries that match the on multiple fields, of course, stock and item stock to index field. You make it a reverse order, but as long as the item one is included in the read pattern, index will be used. So first field of the index must be used. That is there. So you have this thing. So item available sold quantity item. So better than this is the best thing. I gave all the patterns. A slide I kept very few, but in fact, in reality, these many patterns can fulfill the one single index can fulfill these many patterns. These are all, and this one and this one. This is also somewhat good. Rather than looking at everything, at least it is going the key lookup. That's somewhat better than going to the collection. All right, index prefixes means that sort operation. So this is good thing. Mongo has inbuilt intelligent again. If you are sorting on a field which doesn't have index and that data is more than 32 MB, the sort will fail automatically, because sorting is expensive operation. If you don't have a index on it, it will go through the entire collection, it will load into the memory. In the memory again, it has to sort in the order. So it is a double operation basically, not one. Fetching it and reordering it in the memory and giving it to you. So that is very expensive operation. Reading the entirely without a sort is good. If you are reading a data on one field where it doesn't have index, that is equivalent to double computing power. Double. Read out all data and again invest your computing power to sort the data in the memory again. Give it to you as in the sorted order. So that is why in MongoDB, sort operation can obtain the sort order by retrieving the document based on the ordering. So this is what I was saying. When you keep an index on a field, data is already sorted. Sort order does not have to sort again. It will read only the data what it has to read, because sort will go through the indexing and fetch what records it has to fetch, and then sort already done. So it makes really efficient when you're reading it. Anyway, MongoDB has a good thing in it. So sort operation that do not use an index in the sort will abort when they use more than 32 MB of RAM. Automatically it will fail. That's a good thing. It is giving you a warning. Your query does not have an index on the sort field and it is exceeding 32 MB of RAM for its processing, it will fail. Okay, so that's something is too good actually, I would say. Sort on multiple fields. You can sort it on the all indexes fields, but anyway, it will sort on the first field of the index all the time. It does not sort on all. Whatever you give it as a first field, that will be the sort. So if I go to data is not in the order, I wanted to sort. Let's understand this. Sort on S number. 1 means ascending order, -1 means descending order in the sort. So if I read this one, see 1, 2, 3, 4, 5. It is lower to higher. If I give it -1, it comes in the reverse order. It comes in the reverse order. When I doing this sort, is it using the index? Again, you have to check it. If it is not using the index, you're gone. Anyway, Mongo can restrict your query. Your query. Sorry for that. It is using the index scan. It is using the index scan actually. Okay. It is using the index scan, and that's why it is efficient. If you are sorting on one field, this field does not have index, and this sorted data is more than 32 MB, sort will fail. That's a limitation. Okay, this is very important point. Okay, if I wanted to sort, let me ask this question. Let's see what you say. Student dot find db dot student dot find. Okay, I'm going to sort on name. Will it use index? The question. Name 1. So it should be in the alphabetical order, right? It is in the alphabetical order. So Why it is not in the, sorry, it should be S name. Right now it should be in alphabetical order. Does it use index in the background? It's a question. Need to answer this
Yeah,
because we
no, it
discussed it.
won't.
It won't actually.
Yeah.
So if this output exceeds 32 MB, it will fail. That's what I was certifying. So it went with a collection scan. Okay. And then it sorted out. That will take quite a long process, double computing power, which is not, it will fail if your query is exceeding 32 MB. Memory allocation for indexes. This is another topic. We have a good discussion here, but I quickly refer what MongoDB does for the memory. So let me explain. So in Mongo, there are memory will be divided into two parts by default. What percentage I want to discuss in the memory management, separate discussion. The system, we have internal cache in the Mongo, internal cache and file cache. There are two caches in the memory. So Mongo try to keep all your indexes in the memory. How many indexes you create? All of your indexes it will try to keep in the memory. But what is the memory is given to internal cache? What is the memory is given to file cache? By default, we will go with the formula. There is a formula for it. Try to understand. Mongo try to keep all your indexes, whatever you create in the memory. When you have to read some data, the indexing data is available in the memory. It no need to go to the disk and read the addresses and load the data. It has a data address readily available. It can fetch the data more efficiently and give you the result so quickly. Mongo is a memory intensive product. The reason behind is all of your indexes, whatever you are creating, it will try to keep all of the indexes in the memory all the time. Okay, so which will be called as internal cache. Internal cache is completely dedicated for all of your indexes. So whenever we are reading it, indexing reference is readily available in the RAM itself. It does not go to the disk. So what percentage is given here, what percentage is given here, that is separate discussion for us. So this is what internal cache, file cache. That's what memory allocation for the indexing. I did not finish this yet. We have a good discussion there. Multi-key index. Okay, this is also very interesting actually. I'm looking one collection what we discussed already to make it clear. There should be color kind of collection, right? SDB. Did I delete that? It seems so. Student product items, employee, cloud sample class, DBA testing. Anyway,
Last
then
week or
I
before
have to
last week, it dropped, I think.
fine. Let's do one more, just for the sake to make you understand what is actually multi-key index. One index can work on all fields. That's the color again. I'm just doing this again. Color an array, blue, just few records. right? db.color. This is all the data. Try to understand. It's so simple thing. So now I'm going to create an index on one field. This will cover on all fields. One index will cover all elements of the array. That is called multi-key index. So if I'm reading this db.color find and condition as red, color as red. Come on, please. How many documents will read out? How many? Wherever red is there, one,
Two.
two documents. Okay, but how many documents it read in the background to give that output?
Four.
Execution, yeah. It read 4, gave you 2, right? So now I'm going to create an index directly on that field. One index will serve entire that elements. That's the meaning of right. It created. Now if I read this one, it will only read 2. Does not read unnecessarily. So you give any pattern, in fact. You give it. Oh, come on, what happened? See, why was
COLY.
your
What? You.
fine. So now instead of the last thing, I'll give it as black. Color, okay, black. And how many documents will read? Only one, because you have the index. So one index will cover all the fields of the array. That's what is called multi-key index. One index will cover entire elements of the array. That's why it is called one index on multiple keys. That's why it is called multi-key index. It is as simple as it is. Okay. So to index a field that holds array values, MongoDB create an index key for each element in the array. These multi-key indexes support efficient queries against the array fields only. Multi-key concept anyway, you don't need to specifically mention it. It's just a normal index you create on the array field. That's it. So whatever the elements are assigned to that array, it will keep the reference of all independent values against it. So it will read exact values what you're trying to read. It does not scan through. It goes through the exact read because it know the references kind of. MongoDB automatically create the multi-key index if any indexed field is an array. That's it. It's not, there is no special instruction you have to mention to create a multi-key index. It's usual. We cannot create a single index on two array fields. This is something very important. Again, this is an interview question. Let me tell you this. db dot find. Right now, that is the data you have it. I'm going to insert one more field and the same. To insert one more, I have to go to the update, right? I have to go to the update where color green, red, orange, orange. Okay, I can go on two conditions I update. Color. If I give it the red, it will give you 2, right? Sorry, I need to go with the find first. It'll give you 2. Now set. What I'm setting a new field altogether called phones, maybe phones array 2 phone numbers. Okay, it should be comma actually, not dot. So come on, Okay. Oh, come on. I'll do it multi-true to update two records. You know this. What is multi-true? Come on, not there. It has to go inside the load bucket here. Okay, I understand. Fine. Here it need a separate statement. Right. It is match to, but modified one because already done. So now if I go and read, so you got array here, and I'll go with orange, 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 orange. It is done green. What is a common in these two? Violet, green, yellow, purple, orange. Okay, anyway, I'll do it again. Violet. Then black. Just adding a field there, nothing else. Now you see the db dot color dot find. Now you have two array fields. Now I'm trying to create index. See, cannot index parallel arrays. You cannot do the indexing on two array fields. Is it clear? Yes or no? Simple. Okay, time to leave again. It came. Good. Let's give a shot today. Why it was not working yesterday? I did not check anyway. Let's work on db.emp. Do we have emp collection quickly? It should work actually. Emp employee done. eb.emp.insert emp number one, emp name null in either doj new date accepted second record. Okay. Right. Dot find this data you have it. cls db.emp.find. So now let's create the index on this one. Create index on doj. It is a usual index, but you mention as an extra parameter called expire after. Expire seconds. 20 seconds. I'll get quite less. Just create it, then it should expire after 20 seconds. Simply, that's how it works. I did not check yesterday, and if it won't work, I'll check again for sure. Expire after seconds. This is correct, right? Yeah. 20 seconds, not it over. Come on. Not sure what reason it is not working. I did work on this before in the live also. It works. So simple thing actually. Twenty seconds over. Really?
Can we create at a time 3, 4 like that? 2, 3 conditions.
Just a minute. Does not have that process or what? TTL monitor. There should be process. Fremont. Is it missing? About expired transaction. There's something called TTL monitor. That process should be there. Why? Timestamp monitor. Oh, what reason? Timestamp monitor is equivalent to TTL. There is something called TTL process. It's coming as timestamp monitor. I'm not sure. They changed something. There is a background process which is called TTL monitor. I don't see that process. That process should be there in the background. What reason it is missing? If that is missing, it won't clean the data. Anyway, I'll check on this again. I need to check. Anything really changed towards this or not? I did not check recently. Detail index. Come on. It's so weird actually. Namespace. There is no issue with this for sure. Expire after. Right. It looks correct what we are doing. DOJ. This field should go into quotations. I don't think it has to. Quotation makes sense there. I don't think. Does it make sense? Unique indexes will finish tomorrow anyway. What? You are not giving index, it is added the quotations anyway. I need to check this, guys. What reason this TTL index is not working? There is no process called TTL monitor, timestamp monitor. TTL monitor process is missing 4.2 Mongo version. I don't know why it is actually release notes, aggregations, and find missing fields. 4.2 will not start these options. Remove any options by tag. Add support TP and GitHub. I want to working with the TTL. Okay. I mean, just checking if anything is really changed. So TTL monitor thread log. Uh, runs once in every 60 seconds. You can find out the sleep. Let's see. It really gives this. TTL monitor. Okay. The TTL monitor the thread. It should be there.
Do we can see that in Mongo log?
Just a minute. You can disable TTL monitor thread at Mongo startup by. Let me enable this. Is it really? Does that? What are you saying?
Do we can see anything about this in Mongo log?
No,
Log file.
as it is not generic. Just a minute. Maybe if this works, it is a workaround first. Okay, it's not a service account. Maybe. Let's see. It's starting or what? Just a minute. Maybe I'll give last try and then I'll check on. There's something missing in this. Towards that, Mongo is running. Mongo use admin db.shutdown server. No. Right. Come on, I have to start. Sorry. Enable. I have to enable this. Use admin shutdown server. Do we have to explicitly enable this? Current. Do we see TTL monitor now? Client entity logical. There's something called free proger. Wait for majority TTC.
The DB, right? Of
Mm-hmm. T time to stamp again. There's something called TTL monitor. It's a process that is missing for what reason, I'm not sure. Come on, seriously. Okay. Let's see, is it done the job? Still there, I did not. Okay, fine, I'll check on that. There is some issue with our binaries or some problem with it. TTL monitor is not enabled. What reason? These may be enabled.
See, enable only, not enabled.
Enable not defined actually. So, look, was true. It was true, and now OK is also one. So it was true means it's not working. Anyway, fine. We'll see, guys. I mean, I'll check it out. This is a missing piece for me also for now. There is a process it has to run. That process is missing for some reason. Anyway, fine. We'll check on that. No need to worry. Something good topic to know. Fine, fine. We'll see. Any questions?